Well, here's a few news articles. Gag orders. Non-disclosure agreements are allowed in California, although non-compete orders are not. But what's happening is people who are fired for discrimination, like this woman says she was fired from, I think, Pinterest for discrimination. She didn't tell anybody because she thought she would get sued because of the non-disclosure agreement. And eventually, when Pinterest was posing as a company that is supporting Black Lives Matter and being moral on issues like this, she spoke up and didn't get sued, but she might be able to be sued. So they're trying to, a Democratic legislator in California is trying to pass a California law saying you are not allowed to stop people from exposing issues like discrimination from a non-disclosure agreement, which apparently is not clear in national law, but they're trying to make it clear in California law. So that sounds relatively important. They can get that through. This one hit quite a lot of the security press. There is a third-party company that runs security cameras, and this affected Cloudflare and Tesla and many other companies. And apparently, they left a super user administrator name and password available on the internet where they found it. So that was all the hacking. They found the name and password to take them over. And of course, it doesn't sound like they got anything too impressive. They just got pictures of what's being monitored by security cameras from what I can see. But they claimed they had root access on the camera, so they might be able to run software on the camera and do something. But, you know, anyway, it's the sort of thing they ought to patch. But you wouldn't expect a security camera to be picking up anything too secret. Yeah, disclosure agreements are, yes, difficult to understand. But the question is, I think it's never all that clear how much these agreements hold up in court. They have to be tested. So these non-fungible tokens are hitting the news, and I had trouble understanding them until I saw this. They're the same thing as CryptoKitties, and I actually own some CryptoKitties. CryptoKitties are objects on the Ethereum blockchain, and they're just little cartoon cats, but the point is they're all unique, and you own one, and who owns it is recorded on the blockchain. I bought a few of them, and I used to give them away to students for prizes years ago in my cryptography class. And I think I still have a few of them because they got so popular they froze up the Ethereum blockchain, and you could not move them anymore. And then I lost interest. So you can create essentially trading cards. So he got an artist to draw a picture of him doing momentous things in sports events, and then he's created a sort of original card, and there can be a unique card and a unique record of who owns it. So that kind of makes some sense. You can put a collectible on there, and from a technical and financial sense, this is the right move, because the problem with CryptoKitties is you could buy in for just a few bucks. Then some of them went up to like $50,000 and it was crazy. Others didn't. But the point is, since you could buy them for cheap, there was a huge amount of traffic, and the Ethereum blockchain suffers from the same thing as all cryptocurrencies. That's why I'm constantly down on cryptocurrencies. One of the fundamental problems with cryptocurrency is that it takes an enormous amount of energy, an enormous amount of computing time to do transactions on it. So the total number of transactions per second is much, much smaller than other financial agreements like a bank account or Visa. So what always happens is they invent something, they put it on the blockchain, they can run a limited prototype to show that it works, but when it scales out and becomes popular, the blockchain can't handle the load, and it crashes. There is a blockchain that shards to prevent that, but Ethereum does not. Anyway, so, but now one simple answer to that is just sell things that are more expensive, so there will be less units per second sold, and the blockchain can keep up with it. And that looks like what they're doing this time. The same company that made CryptoKitties made these things. So it does make sense. Dapper Labs, that's what they're called. They made CryptoKitties, which came and as far as I know went, but these new NFTs are now all the rage. And various celebrities are making NFTs just sort of like you might have make a commemorative coin or a trophy or something and sell it. A collectible. And that makes a little bit of sense, I guess. It's a digital collectible. Of course, the part that makes no sense is the blockchain part. There's absolutely no reason to keep track of these things on a blockchain. They could just as well give you a little figurine with a serial number that you track the way we track everything else, which is the fundamental problem with cryptocurrencies and blockchains, they're an extremely expensive way to solve a problem that has already been solved in much simpler ways by just a central database. But anyway, apparently anyone can get the vaccine now. Even if you're not old enough or in a special group, all you have to do is volunteer for 4 hours to work at these stations. That's where I went to get my vaccine, a Coliseum, and they just have a bunch of these people standing around in orange shirts. Some of them are just directing traffic. Some are actually doing the injections, and they say if you put in a 4-hour shift, you'll get a free shot of vaccine, so that would be one way to do it. Of course, Biden says there'll be enough vaccines for everybody by the end of May, so presumably by sometime in June, everybody will be able to get it. But anyway, that's an option. Optical quantum computers. I've been waiting for this, and so has the person that wrote this article. The current qubits that are the heart of quantum computers are magnetic, and that means they have to be cooled to a very low temperature, with a small fraction of absolute zero. They don't get it in advance, the vaccine. I think they get it later. Anyway, but now they're figuring out how to do it with photons, how to entangle photons. And the great thing about this is then, I didn't say how cold this has to be, but in principle, if you do it with light, then maybe it wouldn't have to be so cold or so expensive. So they have a prototype, like 8-qubit optical quantum computer. And I always thought that optical computing is probably the way to go here. So anyway, every quantum computing is going forward by leaps and bounds. Everybody is coming up with major advances quite often. So it's still completely too weak to accomplish anything very important and way too expensive to build. But it really looks like in 10 or 15 years, we're going to have some kind of affordable quantum computer that really does something. Right now, it's all just prototypes, but they're making great advances and not hitting any limits that make it seem like it's going to stall out. So Gab got hacked again. Gab is, of course, where everybody went to Parler. All the right-wingers that kicked off Twitter, and then they went to Gab, and Gab got hacked, and they brought it back up, and now it got hacked again. When do I think quantum computers will be viable? Well, it's just a guess. I mean, most people say 10 to 20 years, and it'll be gradual. So right now, Google and other big companies have giant, expensive prototypes that they're doing research on, and IBM has a prototype, and you can use some time on it for free. At least you could for a while, these various ones. It's going to come in gradually. First, there will be some kind of huge mainframe that costs millions of dollars that only one big company can have, and then eventually smaller versions will come out. So it'll be happening over the next couple of decades. I would think it'll be 20 years before you can buy one at home and use it, but long before that, they'll be available in a larger version. And as soon as any of them work at all, then we're going to have to upgrade our cryptography, which is why the National Institute of Standards is currently having a competition which they expect to end in 2022, which will choose new cryptographic routines that we have to switch to, which cannot be broken on quantum computers, because the public key encryption schemes that we're using now can be broken by quantum computers. So it's time to move off of them in anticipation of these quantum computers getting better. So Trump contacted the Republican National Committee and said they can't use his name or likeness to raise money for Republicans, which is pretty harsh. And then they said they're going to totally ignore that and use his name anyway, and they're battling over this. So of course, Trump has made his money for decades by licensing his name. They put it on steaks and soft drinks and TV shows and stuff. And that's, so from his point of view, the Republican Committee is using his name to make money, and they aren't paying a licensing fee. So it's a funny issue. I say people, Lindsey Graham had a very interesting interview talking about why he turned away from Trump and then turned back to Trump. And, he said that Trump has this enormous power over Republican voters, and the Republican Party would like to benefit from his power without the negative things about Trump destroying the party. And they're trying to work this out. If they drive Trump out of the party, a huge bunch of Republican voters will go with him, and they won't have enough voters to win anymore. But keeping him in the party means they have to somehow meet all his demands, and his demands are pretty hard to meet, so we will see what happens. So this woman wrote a book, so we now have a lot of carbon dioxide in the air, and we have to clean it out, and there are plans to clean it out here. But anyway, we're up to the official time, so let me switch to the official topic, because we've got a lot of fun stuff to do today. So we're at Practical Malware Analysis, and the first thing I want to talk about is IDA Pro, which is the #1 professional tool used by serious reverse engineers. And we'll do a few very simple things with IDA Pro. By no means are we going into any depth here. And then I want to demonstrate to you some more stuff about how DILs are imported into Windows software. So let's start with the IDA Pro slides. And then I'll move into demonstrations. I guess I can put this over here. All right. So IDA Pro is a very expensive tool. You have to buy the engine, and then you have to buy the components that connect it to certain languages and versions of software. So you can easily spend $5,000 or $10,000 on your IDA Pro version, but there are old versions available for free with limited functionality, and that's of course what we're going to use. So we're going to use this one here, IDA Freeware version 5. And the old version only does 32-bit code. Have I tried Binary Ninja? No, I don't even know what it is. But I've used Ghidra, and there are some projects in this class about Ghidra. And there's a free Ghidra book. But I don't know Binary Ninja. It might be good. It does the same thing, I guess. It isn't simpler. I know there's a bunch of them. There's also, anyway, these have code signatures for common library code, so they can recognize Windows library. And so the main thing a disassembler does, it was in the video for discussion. Okay. Yeah, I haven't looked at it. There's one of my assistants is running the discussion, so I'd have to see. I should probably look at that then. I didn't know that. Anyway, so here you can see this is the thing people usually think of when they think of IDA. You get these blocks of assembly code connected to other blocks by arrows, and that's an attempt to make it easy to see what's going on here. But this is the other way to view it. This is text mode, where you just see lines of text. And man, I've been looking at this stuff since maybe the 70s. We just have line printer printing out this stuff. So this is the text section. Here's a series of addresses. Here's some instructions like push and move and push. And all these have the same address because these are not real assembly language instructions. These are automatically generated comment lines just to illustrate what this code does. So this is the main routine of some kind of C routine here. And so that's the default, is the in the graph mode display, it looks like this. It puts blocks of code in a little box, and it doesn't show you the address of the code or the binary outline of the commands. It just shows you the commands. So this is not very useful. For example, here it calls the subroutine at 401,000, but I can't see addresses, so I don't know where that's going. So I don't know why they think this is the easy way. So normally the first thing I do is go into options and turn on line prefixes and turn on some opcode bytes. And then you'll see this, where I can see the address and the raw binary, hex here, showing the instructions. And this is usually a lot more valuable. All right, so there's arrows coming out of the bottom of each of these boxes. Red is a conditional jump, not taken. This is the conditional jump taken. This is like if the condition is false, if the condition is true. And then blue is an unconditional jump, where there's not an if statement, it's just a go-to that goes somewhere. And you can have an up loop. If it goes up, then that's a loop that's going to go up and repeat previous commands. So here's an arrow for here's something you compare something and then do a jump not zero. So this is an if statement. It compares something and it might go one way or the other. So it might take the red or the green path from here. If it takes the green path, it goes down here. It takes the red path, it goes down there. But in either case, these now both go here with a blue arrow, which is an unconditional jump. So they always go down here. All right. If you click on anything, then it will automatically highlight all other references to that object. So you will, if you wonder what something is, it'll highlight and make it easy for you to spot other things. The point of this is to make an interactive display that makes it easier to read assembly code and reverse engineer a program at this level, which is a very advanced, very difficult task. As you'll see, we're going to do some very simple cases here, but I often compare this to Photoshop. It is a professional tool with a lot of features to learn about, and you're very valuable if you really learn how to use it. But it's pretty daunting for beginners, so that's why I try to give you simple projects where you learn a few of the simple things to get it going. So here you have a down arrow is unconditional, and then a conditional jump back, a conditional jump down. All right, and these are comments generated by IDA Pro. So here it pushes some address, and it puts in a comment what the string this points to. So this is a pointer to a string. It's able to read the string. Then it's going to call some subroutine that does something with that string, like probably pop up a box with that string in it or something. And here it is pushing another string with another message here. So IDA Pro has added these comments to make it a little easier to read. All right. And you can turn on auto comments if you want to, and then it will put comments on every line, which are a little excessive. Like it tells me this is add and an exclusive or, which is pretty obvious in call procedure. So I usually don't turn these on. The few comments it creates with that thing turned off are enough usually. This but comments on all the obvious assembly language that's pretty easy to read anyway. All right. So the functions window shows all the functions in the program, where they are, how long they are, and a few flags about what they do. Sorting by length might be helpful. Larger functions would probably do more. Here's the names window. This is every address with a name. So that's named data, strings, named code, functions. Then there are strings we've talked about before. These are just strings. It's not like the command strings that just finds every series of bytes that can be read. These are things that are actually stored in a data section and referred to as strings. I think this is the equivalent of OllyDbug's reference text strings, although I'm not sure exactly how it does it. But anyway, now you see all these strings, which is some I use all the time, because as we'll see in the hands-on part here, just as we saw in Olly, if you run 32-bit code on a 64-bit machine, it starts you in an unhelpful place, and it's hard to find the real code. So when I get unable to find the real code, I usually go to strings and find a string with something I can understand like this, and then go to the code with that string in it. And then I'm getting to the code that the developer put there, which is what I want, and I'm not stuck inside some Windows library code, which is not what I usually want to look at. Then you have imports and exports, like we've talked about them. Imports are the API calls it uses in libraries. These are usually Windows API calls, although you can also have custom libraries and custom calls. These are the functions outside this code that it uses, and these are the entry points it puts out. And if it's an exe, it usually has only one entry point because it's only supposed to start in one place. If it's a library, it will have multiple entry points for each of the functions it provides. And then you have structures. So here's some kind of structure, and if you hover over it, it'll pop up a box and show you that this is a data structure with several things in it, and give you some information about them. You can see what address they're at least how big they are. And then there are cross-references. If you double-click the name of a function, it will jump to the location that has it in some other view, and so on. You can double-click pretty much anything in IDA Pro, and you'll go to another view of that object or where it points, and you can find cross-references to things. If you find an object, you can find the calls that use that object and such. So here's how function calls look in assembler, which we've talked about before, I think. But down here, I'm going to call a function called length of a string, lstrlenW. By the way, W in Microsoft language means wide characters, so it's going to count 16-bit characters instead of 8-bit characters, which would typically have an A. Anyway, at least that's what I assume. I haven't read the details of this particular function, but that's normally what this means. So now you push something on the stack, then you push something else on the stack, and then you call the function. This is what you usually do. This is what a call looks like, a push call. And that's why when you go in a function and start executing, the function will then look on the stack and expect to find its parameters. And if you're taking the exploit development class, we were talking about this last time, if you get into a print function and you did not put the parameters on the stack, it will just print whatever it finds on the stack, which was not properly put there because, the assembly is dumb and it doesn't remember the past. So when you go in this function and it looks on the stack, it will find something there and use it, and it will not know that it wasn't put on there properly. All right, if you do turn on these, jump around and get lost, you can do Windows Reset Desktop to get back to a default desktop. It's pretty easy when you're a beginner to click a few things and get lost in IDA Pro. So imports or strings are quite useful. If you double click this string like heap allocate, it will open over here, which is where the word heap allocate is stored. This was a string. It's stored in the text section somewhere, and now you've found where it's stored. All right. If you double click any address, like this address here, it'll display that location. It'll jump anywhere you point to. And there's history. You have back and forward buttons just like a web browser. So if you make a few clicks and you've gone off course, you can go back a few times to get back where you were. I found this very helpful when I was new to IDA Pro. I kept on getting lost hunting for things. Now I've learned how to do like 3 or 4 things I like, and that's all I use it for. And those I can do without getting lost so much. This is super important, and it took me a long time to learn this. When you load a function in IDA Pro, it takes a while to process it, and that is not obvious. So you think you've loaded the file, but it's still chewing on it. And the thing you do is you look at this colored bar. This is the navigation band. And you will see it changing as it fills it in. As it processes the file, it will fill it in with colors. And dark blue is what you want. Dark blue is the user-written code. The rest is stuff like compiler-generated code, light blue, library code, strings, things like that. The code you want is typically the dark blue. And so one way to find good stuff is just click in this bar. This is a single one-dimensional chart of the entire program. So you can click in this bar to get to a region of code in a very general sense. It's one way to find your way around. And another good thing about it is an easy way to tell when it's done processing the program, when this bar stops changing. You can press G, just like you could with right-click Go To in Ollie Debug, and you can now go to any address. If you have an address or a named location that you want to look at, you can search by many things, by text, by a sequence of bytes, or many other things. And there are cross-references. If you're in code and you hover over it, then you'll see it. If you hover over this xref, it will show you what's going on there. So this has a procedure near, and there's a cross-reference here, which shows that there's something that calls underscore main. And this is what I was mentioning before. I'm not exactly sure what's happening here, but one issue here is that if you're running 32-bit code on a 64-bit machine, the actual starting point that IDA will go to is the starting point of the Windows routines that prepare the environment, and only after it's prepared the environment does it actually call the main, which the coder wrote. So there's kind of an issue how to get from where IDA starts to the code. You cannot run the code in IDA. IDA is not a debugger. Although it does have some limited debugging features, they don't work very well and almost nobody ever uses them. If you want a debugger, you use Ollie or Immunity or WinDebug. But so you can't run to the start of it, so you have to hunt around and find it other ways. All right. And if you want to see all the cross-references, you press X, or in some windows, Control-X, and then it will show you all the references to this object. Now, this is the main, so it's only going to be called once by some kind of setup routine, but other functions would probably be called more often. And you can go look. IDA Pro will identify a function. So here it found that something started here at 401040. And so up here in these comments, it tells you it has 3 arguments. It tells you a little bit about the arguments, and that's all. It gives you some information in very general terms about what parameters go into this function. It's not very intelligent. All right, by the way, something we'll get to later is IDA Pro is, by the way, guessing. It is sometimes wrong. You can write code that cannot be disassembled by IDA Pro. It makes assumptions. What it generally assumes is that this code was created by a compiler, like a Visual Basic or a C++ compiler. And compilers have certain standards. And IDA Pro assumes you're looking at that kind of code. So if you make your own code, you can maliciously make code that will confuse IDA in anti-disassembly. Anyway, there are options to draw graphs here. I've never really used these. You can graph various objects. There are some legacy ones, flowchart and function calls that really seem useless. And the others aren't much more useful. You can graph cross-references to show all the paths that get to a function. And one thing I found here is I was able to find, I went to WinMain and it showed one of these graphs, and it showed that in Calc, making Windows Calculator, it calls something called Get Windows Genuine Status, which I thought was kind of funny, sort of suggesting that some feature in Calculator would not work unless you had paid for your Windows. It doesn't seem to me like that Microsoft ever implemented that, but apparently they did include it in the Calculator, some kind of feature like that. And you can do the cross-references from, so if I want to know what would cause Get Windows Genuine Status, I can find out the paths that exit from this, places where it goes, to try to get some idea what it does, which I didn't struggle much more with. And then you can make a custom chart to graph things out. So there may be some case in some complicated function where you need this stuff. Maybe the other calculators like Programmer Scientific. I know, that's what I kind of wondered. But I've used to use the Windows calculator pretty often, and I never hit any warning. Of course, I'm not using unlicensed Windows that often. Anyway, I wonder. I've never heard of anybody having calculator pop-up box saying, you have to pay for Windows, you're not allowed to use this feature. But apparently it does have some code which could be used for that. It may be inactive. All right, and so there's no undo. If you make changes like numbering something or labeling something and you're wrong, you cannot undo it. And you can rename things. So if you find something like a subroutine with just an address like this, you can give it a name, a descriptive name, and IDA will change it every place else. And this is so you can spend your time analyzing code and gradually build up a better understanding of it. But of course, if you're wrong, you're just confusing yourself by putting wrong labels on there. So here's, for example, some raw code. And then after they renamed the argument, they figured out that this is the port number as a string, and this here is the port as a number. So they gave it a descriptive name, and after renaming it one place, IDA will automatically rename it everywhere else to match that. So, if you're accurate in these assignments, you're making the code much easier to read. You can put comments in with colon or semicolon, and you can change the format. If there's a number here, 1,320, that's hexadecimal. If you can change it to base 10, base 8, or base 2 if you want to. And then it will add, hex is nothing. It'll put octal and base here. Yeah, it does. You can't see it very well. There's an H there. It puts an H at the end of hex, nothing at the end of base 10, and octal and binary have letters at the end. So that's a good thing to know. Most modern coding tools will do that. And you can get named constants. If it recognizes Windows libraries, then it can have symbolic constants. So you have numbers which are understood in the context of this function. I'm not quite sure how to get those, but there is some way to get the Windows symbolic constants in there. And like almost every tool we've talked about, it is extensible. IDA has plugins. It has a scripting language, and it can use Python scripts, and so you can go online and download a bunch of extra things, like a decryptor. It will decrypt some encrypted data, something that will export functions to a library file. Here's something that will find format string vulnerabilities by searching through the code. So, there's a whole bunch of these contributed by the world, so you can extend your IDA. All right, so let's take a look at some Kahoots about that, and then we'll start demonstrating some of this stuff. So my Kahoots are here, and I should have IDA. All right, 126. Okay, there we are. Looks pretty good. All right. Maybe we got everybody. Looks like it. Okay. All right. So what feature shows instructions in little boxes connected by arrows? All right, that's graph mode. Good. All right, how do you see user-written code as dark blue lines? Yeah, that's the navigation band. Good. All right, what kind of code cannot be disassembled by IdaPro Free? Okay, that's x64. You can't do that unless you pay money. Or you use another product like Ghidra. All right, how do you switch from graph mode to text mode? Okay, that's spacebar. Good. All right, how do you move to a specific address? Okay, let's go. Good. All right, let's see who the winners are. Max, all right. And Twist, I knew who that is. And Buddy, I know who that is. All right, good. So I'm gonna